execution part is very easy. So design representation should be understandable. The design should be developed iteratively. Design, all the spaces are iterative in nature. The very traditional model, that is waterfall model, except waterfall model, all other prescriptive models are iterative and incremental in nature. So at the time, all the phases, all the framework activities are iterative in nature. So we'll get multiple chance to do planning, communication, designing, modeling, construction, everything. We will get many type. But when it comes to the waterfall model, once we finish one phase, we did not go back. It's completed. That phase means you should collect all the requirement initially. Once you've done the planning, it's done. Again, you won't change it. So once you've done modeling, means it's done. We are going for the construction. So that type of mechanisms only in waterfall model. Waterfall model is not so popular. It's popular only if you know the requirements. It's very clear, and you are 100% sure that I can collect all the requirements before itself. Already established projects to just for increasing its scalability, you can go for the waterfall. The remaining all models, framework activities are repetitive in nature. It's cyclic in nature. So you can change the modification. You can do the modifications. Next is agile modeling principles. Modeling, when it comes to modeling, the primary goal of software team is to build software, not create model. This we need to remember. What is our destination? To build a software. What is our goal? Is to build a software, not building models. So modeling is good. That only support the construction. So, but if you have a very good model, it's not a single model, multiple models are needed to represent multiple perspectives. But if models are there, the construction becomes easy. So the primary goal of software team is to build software, not create models. Next, travel light. So means you should not create more models than you need. You can create models, but you should not spend too much time on modeling. Our intention is to create a working software, that is by the construction back. So you have to focus more on planning and construction. Then strive to produce the simplest model that will describe the problem of the software. So simplest model is always recommended. Simplest model, not only for model, for all the simplest planning. Everywhere simplicity is the main factor. Then build model in a way that make them amendable to change, because need to change. Whatever you created, you need to change. So it should be amendable. Be able to state an explicit purpose for each model that's created. Whatever model you created should have an explicit purpose. So the UML model diagrams which we created, 9 diagrams have, there is a purpose, right? For use case diagram, it's user, represent the user perspective. When it comes to class and object diagram, it represent the classes and objects of that particular software. So the developer, it's a great input. Actually, he can use the classes and object list when he create the actual software, means construction. So when it comes to the other sequence diagram, an activity diagram represent the activity performed by the actor, and use state chart diagram represent the state of operation. So component diagram represent what are the software hardware components you are using in your system, and deployment diagram means what are the nodes here, 3 nodes containing different components. So what are the different hardware parts connecting together? So each and every model represent a meaning. So be able to state the explicit purpose. You've developed the system at hand, try to build useful model. Suppose if you a model and that is not at all useful, you can throw. So try to create a useful model than perfect models. Perfection is secondary. When it comes to usability, you give more importance. Don't become dogmatic about the syntax of model. If it communicates, convince successfully, representation is second. So if your instinct tell a model is not right, even though it seems okay on paper, you probably have reason to be concerned. So if you suppose if you create a model that is not at all relevant for your project, you should not hesitate to throw it. Get feedback as soon as you can. All the models we are creating for communication purpose. So means communicating with stakeholders. Depends on the different stakeholders. You can use different models. And this models, using these models, you can easily communicate. So it's understandable to others. So at the time, you can take the feedback from the stakeholder. So because it's more easily understandable, right? Using to explain something using a model. So these are modeling principles. 10 principles are there. Are you listening me? Are you following me?
Yes, ma'am.
Yes, ma'am.
So when it comes to agile modeling principles, so actually this one is completed. Next is construction. What is construction? Construction means actual coding, right? Coding and testing. Even though we include the testing as a part of coding, that is a final testing. Testing you start from the initial phase onwards. You can test the requirements, you can test the modules, you can test the integrated modules, you can go for system testing. So different level testing is there. But when you draw the diagram, you represent the testing as a part of coding. Means anyway, that is a mandatory testing. Once you complete your coding part or implementation part, you have to go for testing. So the construction activity encompasses a set of coding testing tasks that is operational software. Our goal is to create an operational software that's ready to deliver to the end user. So before you hand over the product to the customer, you need to do a final check. At the time, if you find any bugs, you need to correct it. So coding principles and concepts are closely aligned: programming style, programming language, programming methods. So testing principles and concepts lead to the design of tests that systematically uncover different class of errors. You know why you are going for testing. Our main intention is to uncover the error with minimum time and effort. That is the our goal is to uncover error with minimum time and effort. So that is the construction principle. When it comes to testing, principle means when to stop testing. Is there any particular time to stop testing? Construction means, you know, once you complete all the functionality in the from the requirements, and if the customer is satisfied with the what you implemented, your coding part is over. Means your implementation part is over. But when it comes to testing, you need an error-free software, right? So you have to go for different level testing. Suppose if you create one module, the modularity testing is there, means in the particular module you are testing. Is the functions are working properly? Is the braces are on correct place? It's like a normal program which you are written in the laboratory periods. Small program, like you are checking whether the boundary conditions are correct or not. Suppose if there is a loop, the loop has a boundary values, right? So we give correct boundary values. like small internal checking means whether the class name is correct, whether the function call is correct, whether the function is properly defined or not. Those things we are checking in the module checking. From the module checking, next week, each and every module is testing in that way. So after that, the modules, suppose you create module 1 and module 2. Once you integrate module 1 and module 2, maybe module 1 and module 2 will work independently. But once you join together, you have to go for integration testing. Integration means you have, once you integrate, you check whether both those modules are working together or not. Is there any errors happens that you need to check. So like that, once you complete all the modules, you have to go for integrating with that particular module. You have to go for testing. After that, you complete every module. Your entire system is created. You can go for a system test. There are different types of testings are there. Not only this thing. I'm saying generally. So even once the system testing is completed, you have alpha and beta testing is there. It means developers will check. And you can take the developer means the one who developed the product. And they're very much familiar with the coding part. So they can do a testing. But then also one problem is there that the developer, he don't want to disclose his mistakes. So that psychologically, we don't want to disclose our mistakes. So that testing is needed, but again, possibility of error is there. Maybe there is a chance to hide some errors. So next we will go for with the help of an external support, means you can take a third party help for testing. So those people will come and they will do the testing. At the time, there is a chance to disclose maximum errors, but they may test mercilessly. So there is also some rules how to test. So they will follow that. And after that, from the customer side testing is there. It's not for small projects. This is for expensive softwares. Again, they will implement the same software on the customer side, and we'll do the real-time executions. Still, if it's working and the customer is satisfied, then the last testing is also, it will declare that your is good. Later, maintenance part will be there for some years. If you want to modify that, if the customer needs to modify or change in requirements, you should be there to support. That's maintenance team will be there, and not probably not the developer team itself. So this is the procedure. So next is when it comes to coding part. Before you write a code, preparation principles you need to follow. Means you should understand the problem. You are not started to solve the problem. You should understand the problem analysis is there. Then understand basic design principles and concepts. Then you can pick a programming language that meets your needs. Then you have to check whether you can implement the particular thing, a particular functionality using this software, this environment, and you can select the tools you need to support, and then you can go for test cases. Test cases you can create means test case contain your expected output and inputs and expected outputs. So when you are going for testing phases, actually you are checking whether software meet the expected output or not. So the test case you need to create. That is the preparation part. So before this is preparation means before you start the actual coding. When you start the coding, then Consider the use of pair programming. Select data structures that will meet the needs of the design. Pair programming means multiple programmers can focus on same problem statement, and they can think independently. Later, they can discuss together, and means one means instead of thinking one person, if two persons thinking simultaneously, both of them can generate their own idea, and we can choose the best. So that is a pair programming principle. So in every case, it's not possible, but in some situation, we can use the pair programming principles also, pair programming also. Then select data structure. Select data structures that will meet the need of the design. And what kind of data structures? What are the different data structures you learn? Data structure already over, right? In the previous semester, I think. How many data structures you learn? Are you listening?
Yes, ma'am.
How many data structures we learn? Any examples? You learn one subject, right? Data structures using some language, programming language. I don't know which programming language you learn. Data structure using C, C++, Python. Which one? Which one you learn?
Python, ma'am.
Python. Then what
Yes.
are the data structures you learn? Have you heard about queue, stack, linked list, tree, graph?
Yes, ma'am. Binary search trees at all.
Binary trees are there.
Yes, ma'am.
Different trees are there.
Yes, ma'am.
So all these are data structures only. So when you have data, you can choose the data structure which meet your design needs. So that is the thing I said. So data structures means all these are data structures. Stack, is it a stack operation? When you implement that, you could understand, okay, shall I need a stack operation? Shall I need a queue operation? Shall I need a linked list operation? So that you can design. That is the selection of data structure. Next, understand the software architecture and create interfaces that are consistent with it. Keep conditional logic as simple as possible. Simplicity, as I said, everywhere in every principle, simplicity is one of the principles. Create nested loops in a way that make them easily testable. Nested loops, when you create, you should create in the means. For example, if you create structured programming languages, when you write the program, when you write the loops, there is an order, right? How you're writing the code. The structure you should maintain. So you can easily find out if you miss any braces, if you miss the condition, you can easily find out if you maintain the exact structure. So that is the conditional logic, create nested loops in a way which make you more easily testable. So you can easily understand. If you forget any braces, any conditions, you could easily find out. Select meaningful variable names and follow other local coding standards. Variable name should be meaningful. Actually, there is no restriction like you should use this exact. But suppose if you are creating if you are going to write a software on student details, you can use student student attributes like student name, student ID, like that. You can use the exact variable name which I can give. Then it's more understandable. So suppose if you want, instead of that giving something XYZ, we should use the exact variable name. Then if you make any errors, you can find out easily, and that is more understandable. So actually, there is no particular rule like that, but it's better to follow. Instead of giving something not related names, then it's more confusing. Go for the correct, sensible variable names. Write code that is self-documenting. Create visual layout that help understanding. Like that, your programming should be more readable. Should be more readable. Should be more understandable. More testable. This is the. I should write your program in that way. Okay. When you write the program, some spacing, you have to give spacing. If suppose if you comment, it will understand the readability. It will be more understandable. Not only readability. If the spacing, if you maintain, it will be readable, and at the same time, it's understandable. So that is another thing. Then validation principles. When it comes to validation, after you have completed your first coding pass, conduct a code walkthrough when appropriate, perform unit tests and correct errors you have uncovered, refactor the code. So this is validation. Validation means you're validating what you're validating. Validation and verification process there. Suppose you completed your code. Next is validation. You can go for some testing. If the testing is correct, what is the testing? You are trying to uncover some errors. So if you find out some errors, first you have to clear those errors. You should correct errors. And next you have to refactor the code. Refactoring means optimization, a kind of refactoring. Means you should not change the functionality, but at the same time you can improve the code structure. That is refactoring. For example, suppose your code is working perfectly. Okay, your code is working, there is no error, it does not show any errors. But suppose if there is a variable, that's a dead variable, means you assigned variable to some value, but that value is not changing, static value. Then suppose if I equal to 5, that 5, I equal to 5, that value, there is no increment or decrement for the particular value, means there is no change or updation in that value. You can keep the value outside the loop. Why you are keep inside the loop? Then every time when the loop starts, it will assign the value to the particular variable. So no need of, because it's not changing. There is no calculation in between, and there is no change in value. Then you can keep it outside the loop. So like that, some small adjustment if you do, you can save the time and space also. So that is a kind of refactoring. Refactor the code if possible. But you should not change the functionality. Functionality should be same, but you can optimize the code. Is it clear?
Yes, ma'am.
It's 10:52. Okay. Okay, the time is over, right? Then testing principles I will discuss tomorrow, and I will give you some questions also. Anyway, we completed the third module. Only testing principle is remaining. The remaining parts is over. Principles that guide Francis core principles guide each framework is completed. Only one more testing principle is remaining that I will finish in the next class. Any doubts? Any doubts?
No, ma'am.
Okay. Still, 2 members are responding. Remaining all are silent. Are they listening or not? Hmm?
Listening, ma'am.
Any girls are here in this class? I never heard a girl sound. Only boys are interacting.
Yes, ma'am.
Hmm? Yes, okay then, thank you.